Okay, so good morning, everybody. Welcome to this session on cybersecurity digital market. Okay. My name's Paul Smith from AIT. We're a national research lab in Austria. So I had a speech prepared, but I think we're running a little late, so we'll crack straight on with our first presenter today. So please, take the floor.
So, good morning. My name is Thanh Hale. I'm a senior security consultant in Trust Lab with 15 experience in the security of embedded device, starting with the security of smart card, a field in which the product is designed with the security in mind. And actually, I'm working on different vertical, energy, automobile, pay TV, different IoT devices. And so I would like to give you my point of view about the security approach for smart metering, but also for some different IoT devices, because there is some difference between different verticals. Just somewhat about Trust Labs, where I am working on. So Trust Lab has 16 years experience in the security, particularly in security of embedded device. We have two parts. The first one is for the security consulting, and also we have a labs for the security evaluation. Our labs is certified ISO 17425, and also we are a common criteria security labs. We are working on different verticals: energy, automobile, mobile, and also some emerging topics, for example, how to evaluate security elements in software, for example. About our experience in smart metering, as I say, we have two parts: the security evaluation and security consulting. Concerning security evaluation, we have around 30 security evaluations since 5 years on meter, gateways, but also on some general purpose processor for meter and gateway. Because sometimes our clients come with a meter or gateway with a specific chipset, and they don't really know which is the security resistance and robustness of the chipset, so they would like to have more information and would like to have some confirmation evaluation to be sure that the chipset works correctly in terms of security. We are also familiar with different evaluation methodology. So in France, we use CSPN approach. So it's the approach provided by INSI. For smart metering, just to give you an idea about the duration of an CSPN evaluation. So for meter, it's around 30 days for security evaluation, and for a gateway, it's about around 40 days. And during 30 days and 40 days of security evaluation, we start with a hierarchical checking list in security verification, and then we spend also the time to perform the pen test on the device. We have also experience on the UK certification scheme, so with some evaluation with the methodology CPA. And also the protection profile provided by USI for the gateway and for the secure models. Actually, we are analyzing and following some emerging certification scheme also in Europe. So we can say that we have a global view about the different methodology in Europe, because I think it's very developed in Europe about the evaluation. For the security consulting, we have a global chain starting by risk assessment, define the security requirement. We can analyze security architecture or even perform some code review for some customer. And some authority or some DSO comes to us to see how they can define a certification scheme, because yes, provide some security requirement is the first step, but build a global certification scheme needs experience also on the methodology and certification experience. For me, why we need to have the security for kind of application, smart metering and IoT device. For me, the main reason, there are two main reasons. The first one is the connectivity. So the connectivity generates a very high and large attack surface on the system, and then we put more and more valuable data into the embedded device, and this data exchanged by the network. It's the two main reasons in the connectivity and the fact that the valuable data is stored and exchanged between the embedded device put a lot of threat for this kind of system. So the attack we can have into the embedded device, into the backend side, but also during on the interface and the exchange between the embedded device and the network. And the impact, we talk always about the security impact, but it's not only the main the impact. If we have some attacks, we can have the impact on the security, safety, availability, but also in the privacy, financial, or also impact, and very important for you is the impact on the in-term image. So we should take into account all this kind of impact when we design and develop our system. With our experience in smart metering, we try to compare this vertical with other vertical and try to identify some security challenge specific for smart metering. So for us, the first challenge is the heterogeneity. Because in fact, with the smart metering, you can have the different architecture. So there are many kind of architecture you can have for smart metering. We can have a smart meter, and then with the gateway, we can put also the connectivity modems into the meter. So the architecture is different. You have also the different protocol for the communication part. For example, we can use the cable or wireless connectivities. The functional feature and the security requirement is not the same between different nation, different provider. So it's not easy to provide a common security requirement and security schema for smart metering. The second challenge, so as I say, is the connectivity. And the third technical challenge is that the physical access on the smart meter can give to the hacker a lot of information. It means that, for example, if your GTAC port is not secure, or even secure, but if the hacker can have the access, so disable this control, we can have a lot of information about the firmware, and also perhaps can retrieve some key which is shared between smart meter. For example, also for the flash, if we can remove the flash and dump the firmware in the flash, we can obtain a lot of information. Some customer comes to us and say, we don't really care about physical attacks because it's local. Yes, it's local, but the impact is sometimes not local because we have the same firmware, sometimes we have the same key, so we can use the physical attack, so it's a local attack, in order to understand how it works, a series of smart meter, and then use them to perform remote attack and scalable attack. So physical access into the smart meter, I think, is very important. About the security, smart meter is not always designed with the security in mind. So security, we can say, is the new topic in smart meter. If we compare smart meter and smart card is designed with the security in mind since 20 years. So we have security requirement, you have a methodology for certification. We develop different kind of countermeasure. It's not the case for smart meter. And it generates also the list of security standard and the security evaluation methodology. So Yes, we have security requirement, but how we implement this requirement and how we evaluate this requirement is not obvious. And the attacks in the smart meter can have serious impacts. Denial of powers of some smart meter, theft of power, but you can use also smart meter as a surface in order to attack the grid network, so you can disrupt the grid. So by observing the different products that we have evaluated and analyzed, by observing different movement in the different scheme and different market, we propose. So in fact, it's a classical approach, but we recommend you to consider an approach, security by design for smart metering. So here we can see is there are three typical steps of life cycle of a product: design and specification, development and deployment. Sometimes a developer just only focus on the design, and they are okay, I have a security requirement. Okay, good. But how you implement the security requirement is another thing. You have a product certified, evaluated, okay, but how we can deploy correctly your product into the network and how you surveys, because the life cycle of a smart meter can be 20 years and it's not stop. The security is not ends at the day you deliver your smart meter to the customer. Continue because the attack change, and also sometimes you modify the functional feature. So for the first step, for the design, risk assessment and security specification. I think in some fields, for example, in the smart card, the risk assessment is not very obvious because we have the same architecture, the same specification. So we base on the protection profile to develop the products. It's not the case in smart meter. So you, the developer, but also DSO and also the national authority should consider the risk assessment. So the objective of risk assessment, the first, is not to immediately secure your product, but first is to understand which are the threats on your system. And then to give you your control, because we cannot remove all the risk and all the threat on your device. But the fact that you understand the risk and understand the threat, you can control and have a good understanding of the risk on your system in order to prepare the worst. What happens with when you have an attack? What happens if some security countermeasure is not working? So you prepare the next step in the case that you have some problems with your system. The security is not free, so you have a cost for security. So using the risk assessment, you consider also other aspects, for example, the cost, the planning, and you can select the correct security measure. Sometimes some customers think we have to remove and to treat on the risk and on the threat. Is not correct because it's impossible. You have a lot of constraint in terms of cost, of planning, and also in performance. So you have to select the correct security measure. So is it the goal of risk assessment? I give here some reference for the risk management. So I changed the term from risk assessment and risk management because risk assessment is only one part of the risk management. Risk management is global process, and in which you have the risk assessment. I think the first reference is the base of risk assessment and risk management in the security of IT. It's not a standard, so you cannot certify your product according to this reference, but it gives you the guideline. And based on this reference, different methodologies to perform the risk assessment have been developed. So here we can see in this we have also some guidance to perform the risk management. And in embedded device, we use frequently the methodology TVI. So it's very adapted for embedded device, and this methodology is always and usually used, for example, in the fields of smart card. So just a global figure to explain you how we can manage the risk. We should start with the first step in the context establishment. So, but it's very important part, because in order to perform the risk assessment, we have to understand on the functional feature and on the use case of your target that you want to protect. So you have to define the use case, the functionality, the asset that you want to protect, and also the security property of each asset. So it's a very important step, and sometimes when we perform the risk analysis, we spend a lot of time to understand and to define the security feature. And then the next step is the risk assessment, in which you will identify the risk, you will evaluate and analyze the risk. So it's the risk assessment. But what will we do when we have a list of risks? So you have to treat the risk. So how we treat the risk? It means that you have to develop a security measure, and risk assessment is a continuous process. So you have to review the risk, and also you have to inform the different actors about the risk, because in order to treat the risk, you need not only the time, expertise, but sometimes the cost and the security can have the impact in terms of planning. So to conclude about risk assessment, is a continuous process. It can be done in different steps, and the risk management should involve different entities, because it has a lot of impact in terms of performance, cost, and planning. And then now you have a report about the risk on your product. And based on this risk analysis, you will define the security specification. So I put here a figure from the reference of NIST, and I think it's a very interesting figure. And we can see the separation between risk assessment and security specification. So on the information I explained about the risk management in the first part, it means that we have to start with the use case in order to perform the risk assessment, and then you use this output of risk assessment in order to define the security requirement. And here we can see there is also two parts, the security and the privacy. So you have also to consider the security impact and also the privacy impact in order to define your security specification. And then you can also consider the existing standard in order to complete your security specification. So to conclude about the security specification is a part of risk treatment of risk management process. And after identify the security specification and security measure, you have to control also the residual risk, because with the security measure, you cannot remove on the risk. Some topics that you should consider when defining security measure specification: isolation, root of trust, storage, but not forget the life cycle management, because the product is not only used during the deployment, but starting with the development, you have to protect the asset. For example, how to secure the development environment, because the firmware is developed in this environment. For the security implementation, so now you have the requirement, you have to implement the requirement. Sometimes you have difficulty, so don't hesitate to ask the expertise to help you to implement the security requirement, because sometimes it's very high level. And how to validate your implementation, you should perform the security evaluation, because you are not sure to the implementation is correctly implemented. So different approach we can have for the security evaluation. You can use the black, gray, and white box approach. Each one have advantages but also disadvantages. You can perform not only by pen testing but also by code review and architecture review. And also you should be sure that you take into account the duration of the security evaluation, because it's several months. Sometimes it's several months, and sometimes with some scheme it can take you 1 year to have the certification. So it's very important impact on the security. So during security evaluation, we consider different attacks. You can hardware attacks, so it's not the goal of this presentation, but also the software attacks. Both of them are important because they are direct impact on your device. Last but not least, the security integration, survey, and update is also very important in part because the life cycle of a product is not end at the moment you deliver the product into the customer. So prepare some documentation or process and guideline for the integration. And also don't hesitate to regularly service and update your products and in order to protect against different attacks. So to conclude, I recall 3 main steps that I recommend you to follow in order to secure the products, knowing that it's not only up to developers to ensure on this step. I think all the actors participate in the development and the deployment of the smart meter have to work together in order to ensure on this step. For example, if you have a certification scheme or a DSO, they can help the developers to perform the risk assessment and to define the security specification. The authority also can define the security evaluation methodology. So I recommend you to work together in order to have a security by design smart meter and gateway. So thank you. So it's the last slide of my presentation.
So thank you very much. I shall just quickly, hopefully, bring up the next presentation, which is given by Eres Koran, who's the Director of Business at RAT.
Okay, good morning to all. Thank you. I'm glad to be here. My name is Erez. I will speak with you in a couple minutes about how to tackle the main challenges that we see in the IoT domain. I'm coming from a company called RAD. It's one of the biggest communication and cyber group in Israel. The HQ is in Tel Aviv. You may come and visit us later on. We are on the edge. You can visit me or find nice people like Vicente here, if you may raise your hand. Okay, so I will go together with you about the main trends, main challenges that we want to tackle and how to tackle those challenges. If you look at the market first, the IoT market, so I believe all of us, we are happy we are in a growing market, and this market will grow in 5 years, in 10 years it will be completely different. It's hard to predict how it will grow, but you may see only the power size of the market will double in the coming years. When we look at the different IoT projects all over the world, we see that smart city, energy, and industry are covering around 40% of the market. New verticals are entering into the market. You may see banks, zero energy building, and so on and so on. Before I enter to the main challenges as we see them, some of you, do you have any idea what are the main challenges that we may find in the market? Some kind of things that you saw in the market? Yeah, please. You're right. So I think you heard all over this event a lot of speaking about cybersecurity, and this is one of the main challenges that we see in the market. A lot of devices are all of a sudden connected to the internet using public network. Is this secured? We believe not so much. I can give you an example. A bank, a very large bank, came to me a few months ago just saying that one of their employees did a handshake with the service provider and opened the access to all the ATMs of that bank. It took them a few hours to detect it, and they relied all the time on the service provider, cybersecurity department, and they decided now to do it by themselves. So this is a major issue when connecting to the internet. Another issue is, will there be a single solution for cybersecurity? No. It will be a package of a solution that will fit every organization. So just on July, the US acknowledges Russian hacks US utilities. This is already has been proved. I can say that we saw that in our country. We saw a lot of cyber attacks, and sorry, someone here is from China, coming from China. They have this cyber academy with a live exam. Every time they have this live exam, we see the number of attacks growing up and then going down. And we speak about hundreds of thousands of attacks per day. First proven power outage by a cyber attack. This happened in Ukraine. The attack was done by Russia, putting down around 700,000 homes. Cyber defense by lack, I would say, could result in a disaster. A lot of companies, when they start tackling the cybersecurity, they think, oh, I will put maybe a firewall, that's enough. But that's not enough. There are a lot of different layers that you should cover. The map that you may see here shows you the reason for the cyber attack. What you see here in the purple color, this is all about misconfiguration. So if you do the misconfiguration and a poor integration, basically you are very open to cyber attacks. So this is one challenge that we see in the market. Another challenge in the IoT domain is the operational complexity. Think about replacing a new network from legacy to IP, different protocols, how to connect, how to go to the cloud or to the edge. If in the past we had kind of a simple world from machine to machine, it was basically SCADA on-premise and no internet, all of a sudden we're speaking about mostly TCP, cloud, and internet enabled. This creates a lot of complexity for every organization. For installation, configuration, replacing, and maintaining all the devices. And we are speaking about hundreds of thousands, millions of devices for organization. A typical medium power utility will have more than 500,000 sensors speaking at every given moment. Now think about the protocols, think about the connectivity of these sensors, and so on. So this is the, I would say, challenge number 2, the complexity. And then I want to speak about the data usability. So we speak about a lot about the cloud, and we know Amazon Cloud, they are the sponsors of this event, one of the sponsors. But I think if some of you heard today, there was a presentation by Atos as well, speaking about edge computing. Not all the application could go to the cloud. Think about autonomous cars, for instance. If all of a sudden you don't have any connectivity, you'll have an accident. So in some type of applications, you will need edge computing. You'll need what we call fog application to lower the application to the premises of the customer. Sometimes you need confidentiality. So this also is another aspect why you need the edge computing. We believe in RAD that although cloud is super important and is there to be, and we have the fantastic tools from Amazon as EC2 and Lambda and so on, or the Google or Azure, edge computing will play a critical role for the IoT domain. For instance, when you have validation, estimation, and editing, local processing, you will do it on the edge, not on the cloud. So just to give kind of an idea what's the difference between the two, so we have a common ground. So we have the cloud on the internet, and when we speak about the edge, we speak about devices which are able to host applications. These devices, we believe, should be very flexible, based on containers. So you can download your application. Nobody knows what will be the killer application in 2 years, in 5 years from now. But we do know that we need a very flexible edge, so we can host whatever application that will be there in the market. It could be for smart metering. It could be for ATM machines. It could be for power utilities with sensors. All of these should be able to be logged inside the edge device, do the local process, and then go to the cloud. This middle layer will gain a huge momentum in the coming years in the IoT domain, in all the different verticals. So how do we want to tackle these three challenges? We in RAD, and we work all over the world, from all the way Latin America, North America, Europe, Asia, Australia. We saw some 4 different vectors how to tackle these 3 main challenges. So one of them would be the connectivity. And this is super important when you're connected to sensors or to RTUs or to ATMs or zero energy building and so on. The always-on connectivity. The edge device should be able to have a redundant connectivity, either private radio, cellular, LoRa if needed, or any other communication, fiber, copper, whatever type of communication infrastructure that you have to support it. On top of that, you want to have a redundancy. If the prime link goes down, you need a secondary link to be able to connect immediately. So always on. Remember this, always on, never shut down the communication to the edge. These gateways will collect a lot of data from sensors. You want them to work properly and always be connected. Then we speak about the computing, the edge devices. What we said in RAD, that we believe the containers in the gateways will be the future need for the market. We have chosen the leading container technology called LXD, and mainly you can download whatever application you want into the container. It can host a few different applications, a few Dockers even inside, manage it very easily, and basically give you the full flexibility to manage whatever application you will need today or tomorrow. Nobody knows what will be the killer application for tomorrow in a power utility or in whatever other IoT customer. It could be anomaly detection, another cybersecurity feature. It could be validation or estimation feature, and so on. You want to be ready to host those applications. Security. Of course, this device should have a couple of different cybersecurity means. We speak about end-to-end IPsec. This goes without saying. VPN tunnels over private or public, it doesn't matter. And of course, the ability to host stateful firewalls and so on, maybe IPS or IDS applications. This suite of different cybersecurity features is a must. Now, simplified operation. Think about when going to a customer and he needs to operate now thousands, tens of thousands, or even more devices. All of a sudden, there is a need to do a patch upgrade. It's impossible to send a technician over to the field. We spoke about all the protocols. We spoke about the complexity. You cannot sell a device to the customer and tell him, okay, now it's your problem. The device must, it's a must, it's not a wishful, it's a must, support a secure zero-touch capability, meaning once the device is plugged to the network, it's already connected to the main server, and you can download the main application or patches securely to the remote sites. No need to send a technician. Without this, there is no way a customer will be able to function an IoT infrastructure, and he will not buy from you without this critical issue. So when you have this package of connectivity, security, computing, and simplified operation, this is a suite that will allow you to have the super flexible solution for an edge device that will host all the IoT sensors and then connect to whatever server, whatever cloud that the customer chooses. I think you will hear a lot of presentations today. I will not do it very long. So you're more than welcome to visit us. We're located in the RAD booth. We'll be more than happy to continue and speak with you. Thank you very much.
Okay, Erez, thank you very much. We have some time for questions if you want to field some. Huh? Any questions? No? Okay. He's even left.